So we're going to practice this problem number 1 so that you'll be ready to work on problem number 2, which is the one you need to turn in during the class. In this problem, what you have is the pressure head drop across a short section of an 8-inch pipe is 12 feet. So the diameter of the pipe is 8 inches. And then the pressure head drop is 12 feet. So what this tells me is that delta pressure, or rho g, or gamma, is equals to 12 feet. The pipe section, of course this is constant diameter, doesn't look like here. The pipe section is like this, so we have 8 inches. And it says that it has a globe valve and it has another valve that we don't know what it is. We know that the flow rate is 2.74 cubic feet per second. So we can assume that the friction loss is negligible in this section. So the first thing you always have to do is to write the energy equation. So let's write the energy equation plus P1 over 2 G plus C1. I'm not going to include turbines or pumps because we don't have any. G plus P2 2G plus C2 plus HL. So we have the same elevation, so this cancels. We have the same velocity because the diameter did not change. So what we have here is P1 over rho G equals P2 over rho G plus HL, which in turn we have P1 over G minus P2 over G equals HL. So this is 12 feet, and this is delta P L rho G. So this is my equation that I'll work with. So since I have, let me rewrite that. And this is losses. The problem told me that I don't have any major losses, only minor losses. So this is going to be equal to the summation of the KL values times V squared over 2G. So the first thing I have to do is I have two different valves. One, I know that it's a globe valve and it's open, so I look for the KL value in the tables and it tells me that it's at 10. So I have 10 plus another valve that is unknown times the velocity squared over 2t. Now the velocity I can calculate because I know the flow rate Q is 2.74 cubic feet per second, and if I divide this by the area, it gives me the velocity, so 2.74 cubic feet per second divided by the area, and the diameter was 8 inches, but I want it in feet, so this should give me 7.85 feet per second. Feel free to stop this video at any time. So then I have my equation 12 feet equals 10 plus an unknown times 7, and the parentheses are very important here because this is the summation here. So whenever I look at this expression, when I solve for the unknown and make sure that you know how to do that, pause and study, it is 2.5 2.54. So now I have to look at the tables and see which valve has a K value of 2.54. I could not find it in this generic table, so then I'm looking at other tables, and so I know that then this is a valve, a check valve, the swing type that has a K value of 2.5. So this is the answer. So this is another way of expressing this problem by, instead of calculating the head loss given the type of device, then we are doing it backwards. Hope this helps, and good luck with the second problem.